third bell. I'm so confused. Okay, so we're starting examples today. Alright, in exercise 1 through 6, each C sub k is chosen from the kth subinterval of a regular partition of the indicated interval into n subintervals of length, delta x. Express the limit as a definite integral. So, we have the limit as n approaches infinity. The summation of k is equal to 1 to n of c sub k squared minus 3c sub k delta x. And they say it's from negative 7 to 5. So we're writing this as an integral. Definite integral, so our integral symbol, not that. From negative 7 to 5, so negative 7 on the bottom, 5 on the top. Now, we basically just replace c sub k with x. So this becomes x squared minus 3x, then delta x becomes dx, and we're done. Super easy.
Like that is the answer?
Yes.
You said k becomes x?
C sub k.
C. Okay.
6. The limit as n approaches infinity of the summation from k is equal to 1 to n of sine cubed of c sub x, or c sub k, not c sub x. C sub k delta x, and we have the interval negative pi to pi.
We do the same thing.
Yep. The integral from negative pi to pi, so negative pi on the bottom, pi on the top, of sine cubed of x dx.
The hard
Is it finally taking the trash out?
know.
I hope so.
Yeah, they are.
It's too full.
Can you see it?
Yeah.
Okay. It's like, I can hear it. All right. Any questions on that? Huh? This particular section, just a little bit. But not a lot, though. I think you'll like it.
I was like, the hardest part so far was writing out the problem that we already gave.
Correct.
Yeah, true.
And the good news is I don't make you go the other direction.
Okay.
Like, you don't have to go from this to this.
Okay, cool. Do they make you do that in the book sometime?
I don't think so, but Calc 2, you deal with this a lot.
I need to go look to see if I have to do Calc 2.
I
I don't want to, but
think
I
you
do.
do. But
I need to go check the book.
and you said take college physics, not university physics. Right?
Well, look and read the description to make sure they haven't changed it since I
Right.
was there. But yes, college physics is going to be not calc based. University physics is going to be calc based. So if they give you a choice, take the easy one, because that'll basically be slightly more advanced than what we've been doing, but not requiring you to do stuff like this to solve problems.
I know I have to take physics one. That's all I have to do.
Bye, trash truck. Thank you for finally picking it up. Okay. Evaluate the integral. So I have the integral from 3 to 7 of negative 20 dx. Huh?
Are we doing it by hand or putting it in our calculator?
Oh, by hand. We don't do anything with the calculator with these.
Oh, we
no,
don't?
no, no, no.
Okay.
Not to say your calculator can't, but we're not.
But we're not.
So, I'm going to go back up here to remind you of this lovely constant property that we got yesterday. So, if we have a definite integral from a to b, okay, or in our case from 3 to 7 of a constant, then we take that constant and we multiply it by the difference between the two numbers.
Oh.
Okay? Now, I'm going to do it that way, but then I'm going to show you why that's the case on this one problem. Okay? So, this is going to be negative 20 times, let me make sure it was b minus a, yes.
Yes.
b minus a, so 7 minus 3, which is negative 80. And that's your answer. And before you ask, yes, it does get a little harder.
I understand.
Now, there are a solid 6 problems like this. But I'm going to explain to you what's really happening here, okay? So when we have an integral of something, okay, whether it's a definite integral that has these values or an indefinite that ends up not having values here, we take the antiderivative of this and then we evaluate it at these values here, okay? So doing the other method, not using the theorem, okay, it would be negative 20x, okay, because that's the antiderivative of negative 20, okay? And then we do this nice little bar like this, evaluated from 3 to 7. And what this means is we plug the top value in for x minus plugging the bottom value in for x. So this would be negative 20 times 7 minus negative 20 times 3, which then is negative 140 plus 60, which is negative 80. So see, on a problem like this is the longer method to do it, right? But on other problems, this is going to be the way that we have to do it, basically. And the whole reason that this is true is I have a negative 20 in both pieces. I can take them out, and it would be 7 minus 3 is what's left if I, like, factored it out. So just so you can see it, I would use the theorem personally. Normally, I just disregard the theorem because people then get confused and think that they can do that on everything, and I'm like, but it doesn't work that way. This only works when there's a constant, okay? No variable in here,
Okay.
okay? 10. The integral from negative 4 to negative 1 of pi over 2 d theta. Okay, now remember the d whatever, okay, so d theta, in this case it was dx before, that tells us with what variable that we are integrating with respect to. Okay, so if I were to do this the long way, okay, I'm just going to show you the setup, I'm not going to actually work it out. This would be pi over 2 theta, evaluated from negative 4 to negative 1. Okay, that would be the setup of that. Now, I'm not going to work it the long way because we have a shorthand way that's much easier and faster. So our shorthand way, we take the number that's here, which is pi over 2. Everybody agrees that that's a constant, right?
Yes.
Okay, just checking.
Because pi is a number.
Pi is a number. E is also a number. Okay. I know it's probably excessive that I say that all the time, but it's never failed every year. I have somebody that doesn't understand that concept. So, then we, come on, multiply by the top minus the bottom, so negative 1 minus negative 4, so plus 4. And so then that would be 3 pi over 2. And you don't need to multiply it out to a decimal. You can just leave it like that. Obviously, 3 pi over 2 is something we know, or like we can deal with. All right, let's see. These next ones say to use the graph of the integrand and the areas to evaluate. I'm not going to do that exactly with these. I'm kind of just going to do what I've done in red here with these problems. Except for one, we are going to break it up, but we're not going to actually graph it. But we're going to break it up as if it were graphed so you can see kind of what it looks like. So 14, we have the integral from 1/2 to 3/2 of negative 2x plus 4 dx. So I need to take the antiderivative of the stuff in parentheses. Okay, now the difference is because these are definite integrals, we're not doing the plus c part of when you were just told to find the original function. Okay, so what would the antiderivative of this be? Negative x squared. So if we check it back, bring the 2 in front, that's negative 2, x to the 2 minus 1, so x to the 1. So we're good on that part. All right, how about the plus 4 part? Plus 4x. And we're going to evaluate from 1/2 to 3/2. So I'm going to tell you a lot of times when I'm plugging it back in, or like when I'm plugging it in, I'm going to go ahead and just kind of mentally do the math and write it down, but I'm going to actually write down the full step for this one so that we see it. So this is negative, parentheses, 3/2 squared plus 4 times 3/2 minus, and then I will typically put a bracket because that minus is going to everything. Okay, because when I plug in 1/2 now, that minus has to go to both of those terms. And I just prefer to put a bracket and do that later than trying to remember because I tend to forget a piece of it when I do it that way. So, negative 1/2 squared plus 4 times 1/2. So now, I'm probably going to go ahead and try to get a common denominator with everything as I go, just because I see that I'm going to have, a bunch of fractions here, so I'm going to convert them. So this is going to be negative 9/4. Now, 4 and 2 and the 3 here. The 4 and the 2 obviously would cancel, but since I'm going to try to get a common denominator, I'll do a common denominator next step. Plus 12/2, or well, I guess I can write it as 6 instead. Minus, over here, we'd have negative 1/4 plus 2. So then now, common denominator, I'm going to need 4s on the bottom. So negative 9/4 plus, if I have a 4 on the bottom over here, that means it's got to be 24 on top. Minus, still in the bracket, negative 1/4 plus 4 on the bottom, 8/4. And now I can just combine everything as I go. So negative 9 plus 24. Oh 15. In here I've got a positive 7 over 4, but I'm subtracting, so I was going to be 8 over 4, which reduces to 2. Yeah. And that would be the answer to that one. So something like this is very likely to be on your no calculator portion. Okay, because that's something you could easily do by hand. So I'm not going to say you can't have a calculator to add those fractions, but just know when you get to the exam you probably won't have one. Okay. Trying to remember it's not chapel day. It's weird to have
Yeah, I felt
lunch
it
duty
felt
and
like
not have
Friday.
chapel. Yeah.
On Friday.
I wish it was Friday.
Same.
Okay. Let's see, 20. So this one we're going to have to do a little differently than the one we just did because y'all don't know certain rules yet, which is going to make it a little more difficult, but that's okay. So from -1 to 1 of 1 plus the square root of 1 minus x squared dx. All right, now I'm assuming you don't know what the antiderivative of that is. You might have the first part, but probably not the whole thing, right? So I'm going to see if I can visualize some other shapes, maybe. Like graphed. I'm going to see if I can visualize some other shapes. You know what? Let's just type this into our calculator and look at the graph for a second. All right, plug that in. I'm like, y'all looking like I have 8 heads, so let's just...
The 1 plus 2 or just the...
The 1 plus... Yeah, the whole thing.
Okay.
That was nice. Zoom box. All right, you're probably going to need to zoom box based on what I'm seeing to bring it in because you can't really see the whole thing.
Do we have to type in the dx?
No. You're just typing in the 1 plus square root of 1 minus x squared. Oh, you can't see my screen. All right, so mine looks like this. What does that kind of look like? Sort of. Shape. Like hexagon, circle, square, rectangle.
I was thinking O.
Not a rectangle.
Right.
What?
Rectangle?
It's round.
Circle.
Wait, did you do zoom? What zoom did you do?
Box.
What's the one? Oh, the first one. Oh.
I'm gonna actually go a little bit more.
Why does mine look like that? It's not.
That's what mine looks like.
Okay, yours doesn't look
Circle, probably.
What does yours look like? I'm concerned.
like. Mine's not very
Oh.
whimsical.
It's because you didn't zoom box it.
I did zoom box.
You have to do what I'm doing.
What does that mean?
To go and box it and then hit enter so it makes it bigger.
How do you box it?
Because you have to arrow over, arrow down, hit enter, and then arrow up. Oh,
Hit. You said down. Which one was first? Which direction was first?
we'll go. I always go left and down, and then I hit enter.
Left
Don't
and-
have to go too far. We
Okay.
would just want the object in the. So like
Enter.
how I have it.
Yeah.
So then hit enter, arrow up, and then arrow to the right.
Oh. When you said push zoom box, I thought you meant we just had to push zoom box.
Yeah. Oh.
Okay, now what does it look like?
Half of a
A
circle.
circle.
Semicircle.
Yes. Okay. Semicircle.
There's nothing on mine.
Oh gosh. Your calculator has issues, I think. You have to hit Zoom 6 first. You were still zoomed in from the other day. From the unspoken of problem.
So what do I do now?
You'll find out in about an hour.
Zoom box.
I Zoom boxed it. Okay. Do we all know how to Zoom box?
Yeah.
I didn't know that was a thing.
You know how to
now.
Zoom box, Ethan?
You just go to Zoom and then hit Zoom box.
Yeah, but then you have to outline it.
Enter.
I don't know the outline.
Go.
So,
Oh.
so you would I don't know where my little thingy is. It's a little harder to see right now, but you'd arrow over,
What is what?
hit enter, go up,
So you just go to
hit enter. Oh, nope, I hit the wrong thing. Okay, well anyways, you would hit enter down here. Like when you get over here, you'd arrow it up and then you arrow over to the right and then hit enter and it boxes it. Basically, I've already done it twice, so it's kind of hard to do it on the screen. It's not going to get any bigger.
What's it like? What's the purpose?
So that I can see the graph better. Because, like, originally, the graph looked like that. And it's kind of hard to tell what it is. So, zoom box. So now I've got this whole thing encased in a box. When I hit enter, now I can see what it is. All right, so we said it looks like a semicircle, okay? So I want to think about the formula of a circle. Okay? What is the equation of a circle?
I got this wrong on the ACT.
Like,
No, like the
What's the
equation.
Sorry, sorry, I did say formula. The
I know what
function.
You're saying.
What
I
is
know
the
what you're
function
saying.
for a
I
circle?
don't know what it is.
Like if I told you that I wanted you to graph a circle, what does that like equation look like?
I remember it's
like,
I'll give you a hint. It has an X, a Y, and an R in it.
it's like
Oh,
X,
nope.
X plus Y. Parentheses. No, X plus a variable.
x squared plus y squared equals r squared.
That, yeah.
Okay. X squared plus Y squared equals R squared. So I'm looking at this oh so lovely thing here, and you're probably like, there ain't no way she saw that. Okay, you'll see it with time. But I think that this kind of looks like this.
Yeah, there ain't no way.
Well,
How about if I said
mean, if
y
y-
squared equals r squared minus x squared?
I mean, kind of, because if R's 1, then I understand what you're saying.
Okay, if r is 1,
It would kind of, it would look like.
I'm dealing with a semicircle, which if I traced it around, distance from here, it's almost 1. You tracking?
Okay, yeah, I'm sure.
Okay. So, if I were to take the square root, assuming r is 1, don't these kind of look the same?
Yes. At first when you said that, I was like, it looks like.
I was
that.
like, there ain't no way she saw that.
Okay, so I see a semicircle. But obviously I've got this other little part over here that is happening. And that is I'm trying to see how I can get you to see it on this graph. Hold on. Nope, wrong button. Okay, when we looked at it here, it doesn't exactly look like a circle, right? Or a semicircle.
Yeah.
So there's actually like a little part of this that is making like a little rectangle here. Okay, kind of like boxing off this bottom part, if you will. And that's what this 1 plus part is. Okay. Trying to hold on. I don't think I have that written right. Where is it? That's right. Okay. Now, we're looking at area under a curve. Okay? So we know what shape we're dealing with. So now I want to think about the area of that shape. Okay? So what is the area of a semicircle? Not 2 pi r.
Pi r.
Divided by 2.
Divided by 2. Pi r squared divided by 2. Okay, or 1/2 pi r squared. Okay, this is the area of a semicircle. Now, I'm going to go back to the rectangle in a minute. Now,
What's the rectangle for?
for the 1 plus part,
Oh.
because it's like a piece being added on to the semicircle, and it's hard to see on our graph. If we were to graph it by hand, it'd probably be a little easier to see. But I don't think you know how to graph that by hand. So, when we get farther into these problems, you'll learn how to just integrate this, and you won't have to worry about this part. But we don't know rules of integration for you to know how to integrate this yet. So if you're like thoroughly confused, by the time we're done with this chapter, you won't have to use this method.
Nice.
More or less just showing you what this section wants us to do, and then I'm going to do the easier way. Okay, so what would the radius be of this part if we equate it over here? 1. Okay, so I'm going to replace r here with 1. So 1/2 pi times 1 squared, which is just pi over 2. Now, the rectangular part, in general, what is the area of a rectangle? Length times width. Now, I have, obviously, I don't know exactly what I'm dealing with because my shape looks like that. So it's a little harder to know on this part. But I know that at least one piece of it has to be in the range of 1, okay? Because it's distance from the middle and it hasn't been shifted left or right at all. Okay, so I know that part of it has to be 1. the rectangle, where is it? Oh. But this is, I remember. Obviously, this one is only the distance from here, right? But the total rectangle would be all the way over. So it's going to be 2, and then what you can't tell, but this little mark here, which is really, really tiny, is like 1. Okay? So, again, don't stress about this, but this is going to be 2 times 1, which is just 2. And those areas get added together to give you 2 plus pi over 2 for the answer. Now, again, I would not worry that much about this type at this point, because once we know how to integrate this, because this is something we will be able to integrate later with rules, you won't even think about using this method. Like, I would never actually use this method anymore, knowing integral rules. Okay? Like, I'm probably not even going to give you one like that because I just kind of want you to see, so that way you can appreciate later why you need to know all the integral rules. Okay, 22. The integral from the square root of 2 to 5 root 2 r dr. So I need to take the antiderivative of r, and then I'm going to evaluate from there to there. So what is the antiderivative of r? With respect to r. That's why it's critical to look at this piece of information right here so that you know what you're integrating with respect to. 1/2 r squared. Evaluated from square root of 2 to 5 root 2. So this is going to be 1/2 times 5 root 2 squared minus 1/2 times square root of 2 squared. Okay, now when it's just one piece like this, I will usually just do the minus sign and not bracket it off. The reason I bracketed off this one up here is because there were multiple pieces. So 5 root 2 squared would be 25 times 2, so 50. Divided by 2 is 25. Minus square root of 2 squared is 2, times 1/2 is 1. So this would be 24. And obviously that's much easier than what we just did in the previous one. Use areas to evaluate the integral. So instead of it giving us numbers to plug in, it gives us like a and b or 0 potentially for some of the problems. So 26, we have the integral from a to b of 3t dt. So how would I... Oh, and I guess it also tells us that 0 is less than a is less than b. So it basically just tells us that these are positive and that b is bigger than a. Okay, so what is the antiderivative of 3t? 3/2 t squared, yes.
Yeah.
Yes, that's the same thing, that's fine, but I usually do it in fraction form because it's easier to see the check back. From A to B. Now, what I can do is, because 3/2, is that going to change if it's, like, when I plug something in? Like, 3/2 is going to stay constant, right? So I can do 3/2 times, then I'm replacing t with b and then minus t with a. So b squared minus a squared. And that's just how you would leave that one, because they don't give you numbers to plug in. (28) Integral from a to 3 square root of a. Or wait, I said that backwards. A square root of 3. There we go. And they write it the other way, but I like it looks confusing if you have the variable underneath or not, so I'm taking it out basically. Of x dx. And they say that a is greater than 0, so a is positive. So what would the antiderivative of x be? 1/2 x squared, and we're evaluating from a to a root 3. So again, I can leave the 1/2 out front. So 1/2 times a root 3 squared minus a squared. And since that term's being squared, I'm going to go ahead and like multiply that, but 1/2 times 3a squared minus a squared, which ends up giving us 1/2 times 2a squared, or just a squared. For a constant. Right? Theorem. Okay. So the next problems are like little mini word problems. They're like 1-sentence word problems, okay, with integrals, but super easy. It says to express the desired quantity as a definite integral and evaluate the integral using theorem 2. Theorem 2 is the integral of a constant. Okay, that we wrote down. I don't think I wrote a number with it, so that's why I went to check and see which one it was. So 30 says find the output from a pump producing 25 gallons per minute during the first hour of its operation. Now, something to notice here. This is given as 25 gallons per minute, okay? But notice it says during the first hour of its operation. What's the problem?
60 minutes have passed.
Okay, so the units are different, okay? So 1 hour, 60 minutes. So when we think about this, we need to think about this as the first hour being 0 to 60 minutes so that the units match up. Okay, sometimes they'll give it to you where the units do match up. Like they might have said during the first 60 minutes of its operation, you wouldn't really have to think about this. but the units didn't match, so I need to pay attention to that. So the way we do this is we have an integral from 0 to 60. Okay, so the lapse of time of 25. And then because it's time, we'll do dt. Okay, now theorem 2 is the constant theorem. So now that it's set up, how would I do this, or how would I solve this using that theorem? Yep, 25 times 60 minus 0. Anybody got that number? 1,500, and always, always, always have to remember units. What would units be on here? Gallons, okay, because we're looking for the output.
So not that this would work for every problem, but if you think about it, I mean, just from the problem, you could just multiply 60 by 25 and get the same.
That's the algebra version, not the
That's
Yeah.
that's the output.
That would be the difference between college physics and university physics.
Okay.
Because technically this is like a physics problem.
Right.
Which calculus and physics kind of like intertwine sometimes.
Yeah,
I guess that's why they made a calculus-based physics.
yeah, unfortunately. It's awful.
Did you have to take it, I assume?
Oh, yeah.
Oh, it's fine.
Yeah, it was awful. Don't recommend. Like when you do the homework, it doesn't really matter what method you use, but on the test, the professor's like, I don't see any calculus on here. And I was like, but I solved it, didn't I?
I got the right answer, didn't I? Like,
Rude. Okay. Find the amount of water lost. Sounds like a related rates problem. From a bucket. For now.
for now, but
Leaking 0.4 liters per hour between 8:30 a.m. and 11 a.m.
getting specific now.
Okay, now unit stuff matches up here, right? Because I have hours and I have time that I'm dealing with, right? The only thing is, because we have 8:30, how am I gonna have to write that? Huh? No, I'm saying in hours, but when I write it, because that's what my interval is gonna be. How am I gonna have to write 8:30?
Like 8.5.
Yeah, 8.5. So I have to write it as a half an hour. Okay. So this is going to be the integral from 8:30, or I've said 8:30, from 8.5 to 11 of 0.4 dt, still dealing with time, is equal to what?
0.4 times 11 minus 8.5.
Yep.
If we do that, we will get 1 liter.
Liter. You're not 25, right? I think. Okay.
Yes.
Yeah.
All
I
right.
didn't know what the
I was like,
think about the
25.
question was. I was like, I thought you said you got 25, right?
I
was
also
like,
did.
I did not get it right.
All right, on this last one, I'm going to show you how to use the calculator function to solve these.
Did we learn a little bit about this last year?
Yep,
We didn't learn the hand way.
correct. Taught you the easy way last year,
Yeah.
and I said enjoy it.
It made me think I like calc.
All right, 3 plus 2 integral from 0 to pi over 3 of the tangent of x dx. Now, Do you know what trig function, if you take the derivative of it, gives you tangent?
What trig function?
If you take the derivative of it. No.
That would be the derivative of tangent.
Yeah, that's-
You need to go the other way.
What did you say? Oh, you said anti.
Like secant, wait, antiderivative? So secant x tangent?
There's not one.
Oh.
Yeah, but it's like, there's one that involves
I was
tangent,
really
but it's not just
confused by
tangent.
your question.
There's not one. Okay? Not directly.
Yeah,
So you wouldn't know how to do this by hand, right?
no.
True.
So, fortunately, someone invented this lovely thing that does know how to do it. So we go to, or I'm going to go ahead and type in the 3 plus. I think it's under math. Yes. Okay, now, on your calculator, it's called FNINT. Okay, so you'd hit
Ooh.
math. For me, it's option 9. I don't know what it is for you.
Wait, did we have to add a 3 plus 2?
INT. Oh, yeah. Hold on, clicking quit. 3 plus 2, then math. Whoops. FNINT. Now it brings up your integral so you can type the stuff in. So 0 to pi over 3. Now, does anybody know what we might need to check for on this? What am I dealing with? What kind of function is this?
Does it need to be in radians?
Bingo. Okay. It's a tangent problem. I need to make sure that I'm in radians. And I am, so I'm good. Well, mine goes back and forth because of different classes.
I'm in degree mode.
So you would want to change that or you're going to get the wrong answer. Okay, right? Because we know that the antiderivative of this is going to be some trig function. And if I plug in pi over 3 as a degree versus a radian is going to obviously be a major problem.
Yeah.
So hit enter and we get this lovely 4.39.
Oh,
So could like we use the calculator function to like check our answers?
And your calculator can really only, I mean, I'm going to say this, it can really only deal with x, so just any variable you're going to have to use x for. Like, that button has other options, but it
How do
doesn't.
you get to the other option?
I couldn't tell you. That's something I
It's
don't
like
know how to
you-
do.
you
I've
press
always
one.
wondered that.
Like
I think it has to do with the mode that you're in, potentially, like some mode situation, but I don't know.
well, I'm not
Okay.
gonna go play with the
Well,
buttons.
that is all from this section. So, I'm going to give you some problems.
okay.
Go for it.
1, 5, 9, fumble, 13, okay, 15 I want you to try. It's easier than the one that we did. It's easier than 20 because it is just a semicircle.
There's no like rectangle.
With radius 3, correct. There's no
Oh, okay.
rectangle. So this is just a semicircle. So you'll just be finding the area of that semicircle, basically. Okay?
Okay.
25, 31, and 33.
So you how many sections did you say this chapter had? Technically 4, but we're
5, but we're doing
five.
4.
5 we're doing